Hello guys, welcome to the ACE Online and special welcome to the SSC JE 2024 revision series for the subject strength of material. Guys, I'm going to cover for both civil and mechanical because this is the common for both civil and mechanical guys. Are you getting done, sir? Coming to myself, I'm Hajaratvali. I'm the faculty at Race Engineering Academy. I have secured 14th rank in GATE, 45th rank in ESC. I've done my master's at IIT Bombay. I worked at GE Global Research Center for 9 years, guys. I have been teaching from past 12 years. So you can blindly follow me, guys. So I know what to teach, what not to teach. I know exactly where you have to focus, where not to focus, guys. I will tell you exactly from SSC JE exam perspective, guys. Okay, now coming to the syllabus given. Like in your notification, guys, a typical syllabus concept of stress and strain, elastic limit, elastic constants, bending moment, and shear force diagram, the stresses in composite bars, guys, the torsion, buckling, thin-walled pressure vessels, Rankin's theory, etc. But this seems to be a little confusing. To avoid this one, I have divided into 10 chapters, guys. Simple stress and strains, centroid and moment of inertia, shear force and bending moment, theory of simple bending, shear stress distribution in beams, torsion, complex stresses and strains, slope and deflection of beams, guys, buckling of columns, and last one, thin cylinders, guys. You can ask me the question, sir, how many marks we can expect, guys? Listen carefully. If we take typical weightage, if we take the typical weightage, you can expect, guys, 5 to 6 questions. 5 to 6 questions you can expect, guys, in SSC JE. And those 5 to 6 questions, the level of the questions are not too much difficult. If you prepare GATE or ESC, these questions you can answer very, very, very easily. Are you getting an answer, everyone? The level is, I can say, 50% of the level of the GATE I can able to say. Especially, I'm saying not for all the subject, guys. I'm saying very much particular to the strength of material subject. Okay, sir. Out of 5-6 questions, where we have to concentrate more? From where you can expect a more number of questions, guys? Listen carefully. From where we can expect more number of questions? See, guys, if this is the previous questions, like previous year questions, guys, like past, I have analyzed the past 6 to 7 years of question papers. What I observed is majority of the questions will be coming from simple stresses and strains. First important one. This is the second important one, guys. And slope and deflections, third important one. First priority, second priority, third priority, guys. Are getting an answer, everyone? And complex stresses, fourth priority. Buckling of the columns, guys, fifth priority, sir. If you are a civil, give the second priority for the, I given the priority for the mechanical, guys. For civil, only change is give the second. You're getting an answer, everyone? Because questions are very frequent from the buckling of columns, especially for the civil engineering students. For mechanical, not that much frequent. Are you getting an answer, everyone? Yes. Now, before wasting much of your time, let's start with what are the areas they are focusing more in the specific topic, guys. It is not possible to cover all the topics. So I have chosen the selective topics, guys, like told 1, 3, 7, 8, 9. I have choose the topics, guys. From there, just if you just follow this 1 hour of the session, I can assure that minimum 2 to 3 questions will be coming, guys, from this 1 hour of the session, guys. Because I'm covering each and everything, what is required from the exam point of view. Okay, now observe carefully. First question, let us see, guys. The relation between Young's modulus and modulus of rigidity. Guys, especially the relation between Young's modulus, rigidity modulus, bulk modulus and Poisson's ratio, the questions are very, very frequent. You have to remember these three relations. You have to remember these three relations. Guys, please note down properly because from these questions are very frequent. E equal to 2G into 1 plus V. E equal to 3K into 1 minus 2V, guys. E equal to 3K into 1 minus 2V. E equal to 9 kg by 3K plus G. These questions are very frequent from these three relationships. Like they will give the G value, find out the relation between E and V. They give the K value, find out the relation between E and V, guys. They are going to give the questions from this one, guys. Are you getting or not, sir? Yes. Now observe carefully. From the given question, let us see, guys. He has given the rigidity, modulus of rigidity means GM. So if the G is there, what the formula for this? E equal to 2G into 1 plus. So it is matching with the option C, guys. Clear? Yes. Now let us see this question. This is a very good question. Only if you know the relation, then only you can able to solve the question. As given that when Poisson's ratio is 0.33, greater than 0.33, then which of the following options are correct, guys? See, he is giving with respect to Km, not with respect to G. You should remember the formula. What is the formula, guys? E equal to 3K into 1 minus 2V. Assume it is a greater than 0.33. Assume, guys, V equal to how much? V equal to 0.4. If V equal to 0.4, I assume greater than 0.33 means I can assume so more than the 0.33 value. I'm assuming V equal to 0.4. How much is coming, guys? 3K. 1 minus 2 into 0.4. How much is coming, guys? 1 minus 0.8 will be coming. So answer is coming, how much is 0.2. So 0.2, 3 into 0.2 means how much is coming, 0.6 times of K. So which means that E value is 0.6 times of K, which means that, guys, E is less than K, guys. E is less than K. Just by seeing, I can't able to say, you should know the relation, guys. You should know the relation. E is less than K. Okay, now, see, guys, out of the following, which one is the least elastic? Which one is the least elastic? Let us see who will give me the correct answer for this one. I given 4 materials: silver, rubber, iron, copper. Which one is the least elastic? Which one is the least elastic? Who signifies the elasticity? What material property signifies elasticity, guys? Think about it. Anyone responding? Any problem? My phone?
The axial rotate is 2 times stuck.
Guys, please try to answer this question. Yes, Naveen is saying that it's the iron. Try, guys. But the answer here is, who signifies elasticity? Let us see, guys. Elasticity signifies Young's modulus, guys. Young's modulus. When E is more, elasticity is more. When E is more, elasticity is more. Now, can you please guess it? When E is less, elasticity is less, guys. Out of these 4, which one having the least elasticity, guys? Think about it. Which one having the least elasticity? Yes, it's the rubber, not the remaining metals. You think that, sir, rubber I can stretch it more, no, that is more elastic. No, See guys, I will give a small example here. See, I'm having a two materials. What the elastic property means, guys? I stretch it and then release, going back to the original position, guys. This is the elastic property, sir. After unloading, it should go back to the original position. Now, I'm asking you to compare two materials, material A and material B. Material A, I stretched, released, go back to the original position. I stretched further, released, go back to the original position. I stretched further, it was broken. This is the material A, guys. Material B, stretched, released, it went back to the original position. Stretched, released, it went back to the original position. Now I stretched further and then released. Still it went back to the original position. I stretched further and then released, it went back to the original position. Tell me, sir, which one is more elastic? Material A or material B, sir? It is the material B is more elastic because till maximum load is exhibiting the elastic property. But if you take a rubber, guys, you can stretch it. If you further stretch, guys, it is going to be broken. Okay, sir. I want to compare with the Young's modulus formula. So you please check the E values, guys. 1 second, sir. Please check the E values. Silver having 85 gigapascal. Rubber having just 1 megapascal, guys. Iron having a 205 gigapascals. Copper having a 130 gigapascal, guys. Which one having least elasticity, guys? Rubber is the correct answer. I hope this is clear for you, guys. Let us see who has... Live is coming because doing stuck actually.
Bank left interest rate compare.
It's coming. Good, good. Yes, 1 second, guys. Good, guys. Now we'll go to the next question, Amma. If a material has identical properties in all directions, it is said to be. Tell me, sir. If a material having identical properties in all directions, having a properties are identical in all directions, guys. All directions means isotropic. Tropic means same, guys. Getting us everyone, guys. So isotropic material. It is a typical isotropic material, guys. Now we'll see this question. Yes, this question, Amma. Read the question carefully. I will give you some 5 to 10 seconds of time. Let us see who will give me the answer for this one, guys. Who will give me the answer for this? If P is the tensile stress in rectangular block, here P is the tensile stress, Amma. Tensile stress he has mentioned. Tensile stress, Amma. This one is a stress. And this rectangular block is having a length L, width B, and thickness D. Then volumetric strain is given as. Let us see who will give me the answer, Amma, this one. If you know the volumetric strain formula, you can get the answer, guys. These formulas you can able to get from generalized Hooke's law. Generalized Hooke's law, guys. Please, how can you get, Amma? Listen carefully. You know EV formula, Amma. EV equal to volumetric strain equal to basic formula, guys. Sigma X plus sigma Y plus sigma Z by E into how much, guys? 1 minus 2V. Sigma X plus sigma Y plus sigma Z by E into how much, guys? 1 minus 2V, guys. Now if you observe carefully, guys, here only one direction stress is there. Only X direction, Amma. Because for this block, only one direction stress is. You can assume either X or either Y or either Z. I'm assuming X direction, Amma. So Y will be 0, Z will be 0, guys. So answer equal how much, guys? Sigma X by E into 1 minus 2V. What the most of the students do is, so P, they think that P is a force. So stress equal how much, Amma? P by, are getting answer? P by, I can write P by B into D, they used to write. No. He himself is given tensile stress. P is a tensile stress, means sigma X equal how much, guys? P by E into 1 minus 2V. So it is exactly matching with the option D, guys. I hope this is clear for you. Now, any doubts, Amma? Very good. Very good, Lasya ma'am. Very good. Bukhya Naveen. Yes. Now observe carefully, sir. The property of a material by which it can be drawn into smaller section by application of a tension is called, tell me, sir. Please try this question. Because you are applying a tension load, the moment you apply a tension load, it becomes a smaller. When it can become smaller, guys, the property which signifies what exactly? Ductility, ability to drawn into ducts, ability to drawn into wires. It is a typical tensile property, guys. I can say answer is what exactly? Ductility, guys. Next. The same if they ask the question by application of compression, then answer is what exactly, sir? Malleability, sir. Tension means ductility, malleability is the ability to form a thin sheet. To make a thin sheet, guys, I have to apply a compressive load. Amma. Are you getting that, sir? Yes. Now, every material obeys Hooke's law within its. Amma, this question is a little confusing question. Let us see who will give me the answer for this, sir. It is valid till elastic limit, valid till proportionality limit, valid till limit of proportionality. This question we used to stress in the normal physical classes or in my recorded classes, guys. You can see it. Because very confusing, student used to give the different answer. Because they say either elastic limit or limit of proportionality. Which one is correct, guys? Think about it. Because some exams they given that elastic limit, some exams they given that limit of proportionality. Which one is correct? A or C? Let us see what the answer you're going to give. Very good. Muhammadi has given the answer elastic limit. Teja has given limit of proportionality. Naveen has given limit of proportionality. Let us see, guys. Let us see. What is the correct, guys? Lasya has given limit of proportionality itself. What is correct, guys? Think about it. Guys, observe carefully. Amma, whenever, sometimes elastic limit also correct. When it is correct, Amma? Whenever proportionality limit is not there in the options. Generally, sir, Hooke's law is valid. But what is the Hooke's law, guys? The stress is directly proportional to strain. Am I correct or not, sir? Stress is directly proportional to strain. Here I am talking about proportional itself, which means that it is valid till proportionality limit. Then why in some exams they give the elastic limit is, suppose proportionality limit is not there in the options. Suppose instead of proportionality limit, they given that, as what I am saying, they given that some ultimate point, some fracture point, some yield point they given. Then answer is what exactly? Elastic limit. If proportionality limit is not there in the options, then elastic limit is the correct answer, guys. Why it is correct, Amma? If you observe carefully, guys, if you observe carefully, this is the till proportionality limit. This is still proportionality limit, guys. This is still proportionality limit. And the difference between proportionality stress to elastic stress is very small, Amma. So if you observe carefully, guys, yes, the difference is very small. That's why sometimes the proportionality limit is not given, they can assume as elastic limit itself. Let me repeat, guys. Whenever proportionality limit is given in the options, answer should be no second thought, proportionality limit. If the proportionality limit is not given, then choose the elastic limit is the right answer, guys. I hope this is clear for you. Okay, now. Yes, this question, guys. A mild steel wire is 10 mm in diameter, 1 meter long. The wire is subject to an axial load of 10 kilonewtons. Axial load of 10 kilonewtons, guys. Find the extension of the rod. Amma, the question from this extension formula is very frequent, guys, in the SSC JE. I hope this year also I'm expecting the question from this extension of the rod formula. What is the typical extension of the rod formula, guys? Delta L equal to how much? PL by AE. P is the load, L is the length, PL by AE, guys. Force P into L by AE. Now let us see, guys. What is mean by P, guys, here? P means 10 kilonewtons. 10 into 10 cube. I want in terms of mm, guys. Length is how much, guys? 1 meter he has given. 1 meter means 1000 mm. That's it. By area. Area is how much, guys? Pi by 4 d square. Pi by 4 into d how much, guys? 10 square. 10 square into how much guys? Into E. E value how much guys? 200 gigapascal means 200 into 10 cube. Now what happened guys? This 1000 getting cancelled. Now observe carefully sir. And what I'm going to get amma here. So 10 power 4 I can able to get guys. Listen carefully. Listen. 10 power 4 by pi by 4. Pi by 4 means what exactly? 0.785. 0.785 into how much guys? 2 into 10 power 4 I am going to get because 2 in 10 square and this one guys 10 power 4. So I am going to get guys approximately guys 10 power 4 getting cancelled 1 by instead of 0.7 make it 0.8 easy for the calculation. So I am going to get 1.6 which means I can make it guys 10 by 16 10 by 16 means approximately answer will be 0. Listen carefully sir. I am going to get 16 100 means 16 6 something 3 I am going to 0.63 approximately sir. What is the nearest answer for this one guys? Option C. So C is the right answer. This is the way you have to solve guys. Okay. Next. Yes. One more thing I would like to say. In the chapter 1 questions from Poisson's ratio and the limit of Poisson's ratio very very frequent from the Poisson's ratio guys. Please observe carefully. So you can see how many years they have given 11, 13, 14, 17 just based on the question on Poisson's ratio itself. What is a Poisson's ratio is defined by guys? Poisson's ratio means it tells you guys lateral strain by longitudinal strain. Lateral strain by longitudinal strain guys. Typical definition from this one. Now the Poisson's ratio of a cement concrete is about Poisson's ratio of a cement concrete is about. Let us see guys who will give me the answer approximately. Especially I'm asking this question for civil engineering students because they deal with the concrete and all very frequently. Let us see guys. Very good Naveen. Excellent Mohammed. You are giving the perfect correct answers. Very good, very good, very good guys. Yes, the right answer here is guys 0.15 itself. Especially this table, remember this table. This table guys, please at least this concrete especially sir, concrete, mechanical students especially sir, cast iron and steel. You have to remember this data guys. Concrete, cast iron, steel. At least these three data you have to remember guys. Steel is having approximately 0.3 cast iron is having 0.21 to 0.26. Sir, whenever Poisson's ratio is more, it signifies what exactly sir? Poisson's ratio signifies what? Think about it guys. Let us see who will give me the answer. Poisson's ratio signifies what? This we discussed in the class also guys. If you are my student, we discussed in the class also. Poisson's ratio signifies what? Significance of Poisson's ratio. Anyone? If V is more, what property will be more guys? Yes, V signifies excellent. Somebody is saying more flexible, somebody is saying dimensions guys. V signifies ductility of a material. Just remember guys, V signifies ductility. If V is more, ductility is more guys. Are getting us everyone? Suppose if V is having 0.2, V is having 0.3. The 0.3 material is more ductile compared to 0.2 material. Put a box for this guys. When Poisson's ratio is more, ductility is more guys. Clear? Next. The property of a material by which it can be beaten or rolled into plates is called, without second thought. The answer is what exactly sir? What is answer guys? It is nothing but Malleability, rolled into plates or sheets, then which property signifies, amma? It is nothing but a malleability property, guys. Next, this creep. Amma, based on the property of creep, they given multiple times, amma. So creep, whenever you hear the word called creep means, remember only one keyword here. Creep means time dependent strain. Time dependent strain. Time dependent strain. Okay, apart from all other mechanical properties, guys, only creep is a function of time t, guys. That's why you can easily eliminate other options, amma. Not being ductile, not being brittle, disappearance of deformation after removal of the load, guys. This is called elasticity, guys. Continued deformation with time under sustained load. Sustained load means constant load, amma. If I want to briefly explain the creep property, assume, guys, take a atta duff. You know, guys, atta duff, guys, after mixing with water and all, guys, take a atta duff, hold the atta duff for a moment, guys. The moment you hold the atta duff for a moment, what happens exactly, sir? It will sag. Does the weight is increasing? No. Why it is deforming, guys, with the time? Because the property called creep. Are you getting an answer? Very good. Next. This question, guys. The forces acting normally on the cross section of a bar shown in the figure given below. So tell me, guys, this side force P, this side force P, it gives you what type of stress, guys? Without second thought, compressive stresses will be given, guys. Compressive stresses. Yes, this question, amma, the beautiful question I have seen in the entire, all SSC JE questions, amma, in the first chapter especially, guys. One of the beautiful question I have seen. Let us see who will give this question answer for this question, amma. What is the correct one? Think about it, guys. Here, just a minor correction in the question, amma, like in the figure, they given wrong, amma, here. One plate is there here. Here also one plate is there. Okay. This is the, one is the brass. And second one is the, bronze, amma. Sorry, guys, bronze and copper. This is the bronze. This is the copper, amma. Then which one is correct? You are applying the force P at the ends. Then which one is correct, guys? Let us see who will give me the answer, guys, this question. Who will give me the answer for this? Let us see, guys. Wow, very good, Naveen, excellent. Really appreciate you. Wow, Sharavanan, excellent, amma. Oh, that's guy, great. Very good, very good. Good, guys. How you can say all the options are correct? First thing is, guys, so there are two composite materials are there. You apply the load. When you apply the load, entire load is shared between bronze and copper. So, P equal to shade between, I can write P of bronze plus P of copper, guys. Because entire load is shared between those two materials itself. So, option B is definitely correct. But you know that, guys, if I know the load, how can I stress in the bronze equal to how much, guys? Force in the bronze by area of the bronze. Am I correct, guys? The stress in the bronze equal to force in the bronze by area of the bronze. I can say P equal to force in the bronze equal to how much, guys? Sigma B into AB plus force in the copper equal to how much, guys? I can write sigma C into AC. So this is also correct, amma. This is correct, guys. Okay, then without second I can say this should be correct, amma, because two options are correct. Then how this option A is correct, amma? Very simple. Whenever you apply a load, both will give the same deformation, yes or no? Because I have a plates here. When I try to apply a load, guys, both will give the same deformation. Deflection is same. Deflection in bronze must be equal to deflection in copper. here length is same now, then strain also will be same. The strain in the bronze must be equal to how much, guys? The strain in the copper. When the strain is same, tell me what happens exactly, sir? Stress equal to how much, guys? E into strain. When the strain is same means I can write the stress in the bronze by E of the bronze equal to the stress in the copper by E of the copper, guys. Okay, just rearrange these terms. Sigma B by sigma C equal to EB by EC. So option A also correct. So the right answer is all options are correct, guys. Very good. Next, yes, this is a good question, Amma. The validity of principle of superposition. The validity of principle of superposition. The material should behave in which manner? As we discussed in the class also, guys. Principle of superposition is valid only when, tell me, sir, the cause and effect are having a linear relationship, especially, guys, linear elastic material, only this principle of superposition is valid, guys. Are you getting an answer, everyone? Next, guys, one thing I would like to say. Suppose one thing, guys. If you are my student, if you are subscribed for the online recorded classes, guys, online recorded classes, especially, see there, what I have given is, after every chapter I given a summary, Amma. After every chapter I given a summary, guys. Whatever the points I covered, those things are covered in the summary itself. If you listen the class once, just go to the summary, you can able to answer every question coming from SSC JE point of view, definitely, sir. After every topic is over, I give in the summary. Especially if we don't have a time, at least go through the chapter 1, Amma. Chapter 1, definitely. Out of 5 questions, guys, 2 to 3 questions will be coming from chapter 1 itself. So just mark my words, guys. If you don't have a time, go to the chapter 1. Simple stress and strain topic, guys. You can easily able to answer from the summary I have provided in the summary section itself, guys. Like that, I have provided summary for each and every chapter, guys. If you're having some fundamental basic idea, directly go to the summary. It saves your time, guys. You can able to recollect what is the information provided in the chapter, guys. Are you getting an answer, everyone? Yes. Let me start with, yes, a square block. This is a question on complex stresses and strains, guys. A square block is subject to a state of simple shear. The linear strain of the diagonal will be equal to, I have clearly mentioned as a special case in the class, Amma. That is what, whenever, listen carefully, sir. Whenever a block is subject to a pure shear, if the shear strain is how much, guys, exactly, sir? The shear strain is gamma. Then what is the diagonal strain will be, guys? Because of this one, what happened, Amma? This will try to deform like this. The diagonal will be having a elongation, Amma. Diagonal will be having elongation. What is diagonal strain? Diagonal strain equal to how much, guys? Let us see. Anyone will give me the answer, Amma. Diagonal strain equal to how much, guys? Let us see. Anyone remember this formula? This we discussed in the class. Diagonal strain equal to how much, guys? Excellent, Sharavanan. Sharavan, very good, Nana. Your answer is correct. So diagonal strain equal to how much, guys? Gamma by 2. Diagonal strain equal to gamma by 2. Sir, how we got, Amma? You know the strain transformation equations, guys. Strain transformation equations. Diagonal strain E theta. Listen carefully. E theta. Ex, these are 0. Why these are 0, guys? Because it is having a pure shear itself. Okay, this one also will be 0. The answer equal to how much, guys? Gamma xy by 2. Gamma xy, the shear strain, into diagonal. How much angle, guys? Angle will be 45 degrees. Sine of 2 into 45 means sine of 90 degrees, guys. Sine of 90 degrees means how much, guys? 1. The answer equal to how much, Amma? Gamma xy by 2. So E theta equal to how much, Amma? Gamma xy by 2. So it is a half of the shear strain itself. Very good, Amma, very good. Muhammad, I hope this is clear for you, Muhammad. Yes. Now, which of the following statement is true? Shear stress on principal plane is 0. Shear stress on principal plane is maximum. The shear stress on principal plane is minimum, and none of these. Which one is correct, guys? Anyone? Which one is correct, guys? Which one is correct? What do you think? Which one is correct, Amma? Yes. If you observe carefully, sir, if you draw simple Mohr circle anywhere, see, this is the normal stress, this is the shear stress, guys. Normal stress, shear stress. This is the maximum principal stress, this is the minimum principal stress. Getting yours, everyone, guys? And on this plane, what is the value of shear force of shear stress equal to how much, guys? 0. I can write shear stress on principal plane equal to 0. Then I can pass one more statement also, guys. Can we say that definitely, guys, shear stress on principal plane is 0. Can we say that suppose I am having some plane, on that plane shear stress equal to 0. Can we say it's a principal plane? Let me repeat my question. First question is shear stress on principal plane is definitely 0. Now I am saying that on a certain plane, if shear stress equal to 0, can we say it's the principal plane, guys? Think about it. Think about it, guys, everyone. Let us see who will give me the answer, guys. Okay, Shravan is saying that on any plane the shear stress equal to 0, there is not a principal plane according to Sharavanan. Let us see, guys, about other students also. Guys, try to give the responses. Try to give, guys. So Naveen also saying no, excellent, very good. Others also please try to respond. My question is, my question to you guys. Suppose on any plane if the shear stress equal to 0, can we say that is a principal plane or not? Think about it, guys. Yes, answer is Madhu is saying again no. Let us see, guys. I'm expecting few more answers. Yes, Vishav Singh saying that yes, Smiley Singh saying that no, Jyotika ma'am is saying yes, Sagar is saying yes, but let's see actual answer is, guys. The actual answer is no, according to most of the students, but this is absolutely wrong, Amma. Actual answer is yes, guys. But the question is again, why? Guys, tell me, sir. Because simple logic, in Mohr circle what happened, Amma? Each and every point is one plane. Because each and every point on the Mohr circle is a plane, Amma. Yes or no? Can you tell me any plane other than the principal plane shear stress equal to 0? Listen carefully, sir. I told you, in Mohr circle, this is one plane, this is one plane, this is a one plane, this is a one plane. What is the question I asked, guys? On any certain plane, if the shear stress equal to 0, can we say it's a principal plane or not? That is my question. Yes, the answer is yes, guys. On any plane, if the shear stress equal to 0, because shear stress will be 0 only on the principal plane. In all other plane, having, suppose if you take some plane, Amma, this one, yes, some shear stress exists here. If you take this plane, some shear stress exists, guys. Only on the principal plane, shear stress equal to 0. So, shall I pass this statement, guys? In the question also, if they given shear stress equal to 0 means that plane must be a principal plane itself. Do you understand, sir? On any plane, if the shear stress equal to 0 means that plane must be a principal plane, guys. I hope this is clear. Very good, guys. Next. When a member is subjected to an axial tensile load, the greatest normal stress is equal to, the greatest normal stress is nothing but what exactly, sir? The greatest normal stress means principal stress, guys. maximum principal stress or major principal stress is equal to half of the maximum shear stress is equal to maximum shear stress, twice the maximum shear stress, and none of the above. Can you please tell me, sir? What is this value, guys? Can you please tell me? Let us see, guys. Who will give me the answer for this? Think about it. Properly think about it, guys. Axial tensile load, the maximum, the greatest normal stress is equal to. That's great. Let us see who is going to give me the answer, guys. Think about it. Really, I'm really happy, Amma. This equal to, okay. No, sir, I don't have any idea and all. I told you to remember the, it is a uniaxial tensile load. Only tensional stress is present. Only one-dimensional stress is present, Amma. So I can write sigma x equal to sigma itself, sigma y equal to 0, tau xy equal to 0, guys. What the center of the Mohr circle formula? Center equal to sigma x plus sigma y by 2. So how much is coming, guys? Sigma by 2 itself. What is the radius of Mohr circle formula, guys? Square root of sigma x minus sigma y by 2. Sigma x means sigma itself. Sigma y means 0 by 2 whole square plus tau xy whole square, guys. Tau xy means 0 itself. Answer is how much, guys? Sigma by 2. So center and radius both are same. When center and radius both are same, which means that, guys, the Mohr circle exactly touches what? Touches the origin. This is, tell me, sir, this is sigma, this is tau. Here I can say my center equal to radius, guys. Then only can able to touch the origin, Amma. Tell me, sir, where is the maximum shear stress, Amma? This is the maximum shear stress. What is the maximum shear stress value? I can say radius of the Mohr circle. I can say, guys, tau max equal to how much, Amma? Radius of the Mohr circle. Am I correct or not, sir? Now, what is the maximum normal stress value? This is the maximum normal stress. Minimum normal stress is 0. Maximum how much, guys? This is the maximum normal stress. This value equal how much, guys? 2R. I can write sigma max equal to how much, guys? 2R. But R equal how much, guys? Yes, tau max. I can say, guys, please observe carefully. It is twice the maximum shear stress. The answer is matching with the option C. I'm very happy that few students has given the answer perfectly, sir. So I can say like Sharavanan and Jyotika ma'am and Buddy Shah has given the correct answer itself. Very good, Amma. Vinay. Really happy for that, guys. Let us see. If the cantilever beam carries a uniformly distributed load, if the cantilever beam carries a uniformly distributed load over its entire length, then shape of the bending moment diagram is, what is the typical shape of the bending moment diagram is, guys? Typical shape of the bending moment diagram is, see, guys, here I would like to say 4 examples, Amma. Mark my words, for civil or mechanical, one question will be coming from next 5 minutes, guys. Listen carefully. I am not going to solve any question, guys. I just give you few formulas. One question will definitely coming. Just after the exam is over, just go through this slide, Amma. You will get one question from this slide, guys. Because I observed the past 10 years, guys, question paper, one question will be definitely coming from this slide itself. Just go through it. Remember, Amma, this basic few formulas. First one, cantilever beam subjected to point load P. Just please write down, Amma, these formulas. Very, very important. Even in the sleep you have to remember, Amma. Then maximum shear force, how much, guys? This is a typical, listen carefully, this is a typical shear force diagram. V max equal to how much, Amma? Applied load itself, only magnitude I am writing, guys. This is a typical bending moment diagram. This is 0 here. This is how much, guys? P times of L. So M max equal to how much? This is the M max, Amma. So M max equal to how much, guys? P times of L. Next, you need to remember two other formulas also, guys. That is what? Maximum deflection. Delta max in this case. Delta max equal to PL cube by how much, guys? 3EI. This is the maximum deflection. And maximum slope. Theta max equal to how much, guys? PL square by 2EI. You have to remember these two formulas. Where you will get the maximum slope, guys? Listen carefully, sir. Same thing. Whenever load P is acting, yes, this is the theta max. This is the delta max, guys. Clear, everyone? Yes. Now, coming to second one, Amma. Coming to second one. Second one. Particularly, cantilever beam subjected to UDL load. UDL load. Where is the maximum deflection, guys? W Newton per meter. You should remember, Amma. Where is the maximum deflection? This is the maximum deflection. Slope also, this is the maximum slope, guys. So whenever UDL is the deflection formula, guys, W L power point load L cube will be coming UDL L power 4 by how much, guys? 8 EI. Then maximum slope how much, guys? WL cube by how much, guys? 6 EI. Then I need to find maximum shear force and maximum bending moment. For this one, where is the maximum shear force and maximum bending moment? At the fixed end, we are having the maximum shear force and maximum bending moment. How is the shear force diagram, guys? It is varying linearly. This is the shear force diagram. The maximum will be coming WL, guys. This is the maximum shear force, like shear force diagram. How is the bending moment diagram, guys? A parabolic variation. It is a linear. When the load is UDL constant, shear force will be linear, guys. It's having a parabolic curvature. Quadratic function of x square, function of x square, parabolic itself. What the formula, guys? Anyone? M max W into L by 2, W L square by 2 is the maximum bending moment. You have to remember, Amma, this one. Third one, listen carefully, guys. Third one, everyone. Subjected to pure bending moment M, pure bending moment M, then maximum deflection equal to how much, guys? ML square by 2EI, and maximum slope equal to how much, Amma? ML by EI. Then what is the shear force, guys? Shear force maximum equal to how much? Let us see. Anyone remember this formula? Let us see, guys. Let us see. Anyone remember this V max formula, guys? Let us see. V max. Think about it. Think. What is the maximum shear force in case of a moment, end moment M is acting, guys? Very good, Jyotika ma'am. Excellent. Excellent, Ahmad. Yes. Maximum shear force equal to 0 because no shear force exists. The pure bending moment is acting on the beam. No shear force exists, guys. But I'm having a maximum bending moment equal to how much, guys? Everywhere same M will be present. M max equal to M. This is a typical shear force diagram. Everywhere M is constant. That equal to how much, guys? M itself. These three formulas, especially maximum deflection, maximum slope, V max and M max. One question will be coming, guys. The story is not over. We are having a simply support beams also, guys. Simply support beams also. Fourth one, guys, have a simply supported beam subjected to point load P. Then support reaction how much guys here? P by 2, P by 2. How is the typical shear force diagram? Ma? This is the typical shear force diagram. So this is the P by 2 value varying from plus P by 2 to, just remember amma, this minus P by 2, again minus P by 2 to 0 guys. Here definitely I can able to say maximum shear force equal to how much guys? P by 2 itself. Okay sir, what is the maximum bending moment then? Maximum bending moment. So definitely at the starting it is 0, at the starting also will be equal to 0. You get the maximum bending moment as this value guys, how much guys? P by 2 into L by 2, I'm getting PL by 4 is the maximum bending moment I'm going to get at the center. Next, listen carefully guys. And story is not over. I'm having a maximum deflection. You get the maximum deflection at this location guys. You get the maximum slope at this location. Anyone remember amma? Maximum deflection equal to P L cube by 48 EI, and maximum slope equal to how much guys? P L square by 16 EI. Direct formulas they used to give you guys, subjected to point or what is the maximum slope, what is the maximum deflection guys. Direct questions they used to give them. Next, fifth one guys. Same cantilever beam subjected to UDL guys, W Newton per meter guys. This is the typical shear force diagram. This is a typical bending moment diagram guys. UDL is it be having a quadratic in nature, parabolic curve you will be getting sir. Here definitely sir, the maximum shear force equal WL by 2. Then anyone help me guys, what is this value amma? What is this value guys? I'm going to get WL square by 8 I'm going to get guys. Please try this one guys. WL square by 8 I'm going to get the maximum bending moment at the center guys. Then maximum deflection formula equal to W L power 4 by 5 by 384 W L power 4 by EI, and maximum slope equal to how much guys? Maximum slope equal to, I'm going to get WL cube by 24 EI. I'm going to get the maximum slope guys. Clear everyone? Yes. Now we'll go to the question summary. This question has given, if it is a uniformly distributed load, then shape of the bending moment must be equal to how much guys? Shear force must be how much guys? Should be linear. It should be quadratic parabola itself. The answer is option B. Now, these questions you have to understand guys. Now let us see. For the cantilever beam shown in the figure, the value of the shear force at the fixed end is very simple. You know that guys, due to shear force, due to point load, shear force equal to how much guys? P itself, you can see. Due to point load, shear force equal to P itself at the fixed end equal 25 plus, due to UDL how much guys? Due to UDL like given guys. So W times of L guys. Here W 30 times of L means where it is acting only 1.5 guys. I am going to get 25 plus 45. 70 is the answer guys. Option is option B itself. Okay. Now, which of the following beam is likely to have a point of contraflexion? Generally guys, the beam with overhang beams, while you are solving the problem you get the idea guys. Beam with overhang beams, simply support means will never have a point of contraflexion guys. And for simply support beam shown in the figure, the magnitude of the vertical reaction at B, the formula, simple formula is guys, whenever unequal loadings are there, it should be what guys formula? Just remember this formula guys. Here it is P B by L. Here how much amma? P, sorry guys, this is the A, this is B I to, this is the P A by L, this is the P B by L guys. Asking at B is asking amma P B by L. So P is how much amma here? 30 into A how much guys? 1 by 3. The answer equal 10 kilonewtons guys. So option D is the correct answer. Very good, Amma. Next, find out the correct matching, guys. This you can able to do it with point load under the tip. Wrong. Please, you can try to give me the answer, Amma. I given everything, Amma. Under UDL, this is the correct answer, guys. You please check all the formulas I have mentioned already, guys. The previous slide. Those 5 points I have given, sir. The questions coming very frequently from that topic. So please mark my words. One question will be definitely coming from those 5 formulas I have given. Okay? Yes, you can see. The column, if you take us, the column with highest equivalent length has both highest equivalent length, Amma. Both ends fixed, both ends hinged or pinned, one end is fixed, other end is entirely free, one end fixed, other end is hinged, Amma. The answer is option C. Having a highest equivalent length, as you can see, highest equivalent length is having a one end fixed and other end is free. You have to remember, Amma, the questions are very frequent from this effective length formulas also. Next, what is the expression for cripping loads for the columns with both ends are hinged? Just how we discussed. P critical equal to how much, guys? Pi square EI by LE square. But LE equal to how much, guys, in case of both ends hinged. Both ends hinged means what exactly, sir? L itself. Answer is L itself. Pi square EI by L square. The answer is coming with the option A itself, guys. I hope you enjoy the session, Amma. You enjoy the session. Okay? And if you want to have a further guidance from us, guys, as we discussed already, guys, I myself have taken a SSC JE class for strength of material in the recorded classes, guys. I clearly given what is important, what is not important. I provide the summary also, guys, in detail. Are you getting answer, everyone? You can utilize that one if you're already our student itself. Okay? And if whenever whenever you need any support and any guidance and all, guys, we're always there for you, guys. So you please write a mail, guys. And so one thing I would like to announce, Amma, we are conducting the grand mega mock test on 26th May. 26th May, guys, from 1 p.m. to 3 p.m. Just fees is only 100 rupees, Amma. Okay? Just fees is only 100 rupees. You can ask the question, sir, why the fee you are keeping, sir? Earlier, we used to give at free of cost, guys, but students are not taking that much serious. Because we are putting a lot of resources. The faculties are giving the very quality of questions and all. Having a proper IT system we are having, guys. Are getting an answer, everyone. So for that minimum charge we are keeping, guys, 100 rupees itself. You can utilize this one. Always AC is there to help you, guys. I hope you will definitely get a success in the exam, guys. 1 second, Amma. Yes. You will definitely get a success in the exam. Wish you all the best, guys. If you're having any queries, you can ask in the chat session, guys. Very good. So many students. I'm really happy that so many students has actively participated while giving the responses, guys. I'm really thank you, guys. Thank you so much, Amma. Wish you all the best. Madhu, you please call to the contact number we are providing. Like you can search in the ACE online website, guys. You will find out. You'll find all the details, guys. Okay. Yes. Thank you, everyone, guys. Thank you, everyone, to make this session very pleasant. Already given. Okay, guys. Wish you all the best, Amma. With this, I'm stopping the session. Thank you so much. Thank you so much, guys. Thank you. Guys, I mean, sir, Swami exam is a online exam, amma. Exam is a online. You can search. Exam is an online exam, amma. It's a mode of exam is a online mode. They're conducting from civil, mechanical, and electrical. Okay. Yes. Naveen, the subject assumptions, basically we are having only 3 to 4 assumptions. Metal is isotropic, metal is homogeneous. Are you getting it, sir? The metal is having a superposition principle is valid and all. Very few assumptions we are having, guys. Okay. On formulas, there is no way, guys. You have to write down what are the important formulas, especially, sir. Especially deflection formulas and shear force and bending moment, maximum shear force formulas are very, very important, guys. Very, very important. Swami, I hope I answered your query. So, it's a mock test is a online mock test, amma. Okay. Good, guys. Good, guys. Good, guys. With this, I'm stopping the session. Thank you so much, guys.